Alright, we should be good. So let's now use this separator again to kind of separate the classes. And then let's actually create a function that we can call from Max itself. So let's create a function like a setup function. So function setup. Oh, this is not a class, as you can see, because I wrote it with not with a capital letter. This is just a function that we will call from Max. This will be where we create our creatures. So setup of the ecosystem. So let's create actually a variable. This will be our global variable. This will be our creatures array. We probably will want an array of those creatures, but let's just start with one. So var creature, and then let's assign it inside the setup function. Let's assign a new creature to this creature variable. So new creature, and that's it. And then let's create kind of a draw function draw, a bit of in processing style of coding. So function draw, and let's say creature dot display. And this should work. First, before displaying the creature, we actually have to reset the mySketch command line, command list, because otherwise the sketch will continuously, if we call this function draw every bang, the sketch will continuously fill its command list with the same commands, and this we actually don't want. We first want to reset it, and then to tell it to display the creature. So this mySketch reset, we will call it at the beginning of the draw function. So let's see what we get. So if I say setup first, this we can actually connect it also to a load bang, because this function maybe we want to call it at the beginning of our when we open our patch. And then let's try to draw a new creature. So okay, there is an error, line 112. There is apparently an error, yes, because I missed a dot here. So let's try again. Oh yeah, this is our creature just appeared here. Will be kind of nice, I think, if this would have like a black border, a black edge, this circle, so our creature. Let's actually make it also a bit not so bright, the white of the background. Alright, and let's create kind of a black border for our creature. So I go inside the JavaScript. So before we display it, let's create kind of a circle with an edge. So what was the command again? Let me check in the GTL sketch help file. So the command was frame circle. Okay, so let's write, before we draw the circle, let's actually write mySketch.frame circle, which will be like this size plus 0.01. So let's see what we got. Okay, this is much too much. So plus 0.01 or 2. And okay, first we draw the normal one, then we assign the color of the sketch to black, so it will have a black border. 0, 0, 0, 1 for the alpha. You know, actually we can call the setup function directly inside here from the JavaScript by simply writing it in the global code. So we don't even need to actually call it at startup. And no, made something wrong, because apparently it's drawing our shape in black, even if we actually are drawing the shape first in red, and now we are changing the color. Ah, I know why, because we don't have to use the color parameter of the GTL sketch, but we actually have to use the function GL color. I think this is the problem. So So let's try like this. Alright, it's working. So yes. Let's maybe put it a bit farther from the shape. So okay, it is a bit too much. So let's actually make the line width of the sketch object a bit bigger. So this can be kind of done globally here. So GTL sketch line width equal 3, for example. So let's see. Okay. So give us a bigger one. Okay, that's kind of looking as I meant, as we wanted it. Okay, so super. Let's create now more of these creatures. So let's create kind of an array of these creatures. So for the moment, I said before that we will create several creature classes that will all inherit from this main creature one, but for the moment we are just playing with the main creature class without creating actually the other classes. So for the moment we are just experimenting and seeing if the code works by using this main class. So let's create actually an array of these creatures. So instead of creature, let's write creatures, and let's create this as an array. Let's create a for loop in our setup function. So for var e equal to 0, e less than, I don't know, let's create 20 of them, e plus plus, and then let's say creatures dot push new creature. Okay, so this will fill our array. The problem is that in this way, every time we save, the creatures array will just get bigger and bigger. So in the beginning of the setup functions, we had to say creatures equal to an empty array. So now every time we save, it will execute the setup function, first empty the array, which was already existing, and then pushing new creatures inside it. Okay, and then display, we need to do something different. We need to do also a for loop, so we can just actually copy this whole little chunk of code. And then let's say creatures I dot display. Okay, so let's try. Probably we will have to adjust the dimensions of our... Oh, and they all start in the same position now. So let's actually make the creatures start from a random place in the world. So let's actually make them start from in a random place between -1 and 1 on both axes. So let's say var random x equal to math dot random, and then we want to bring this range from 0 to 1 into -1 to 1. So let's multiply by 2 and then subtract 1, and then var random epsilon equal math dot random, and multiply by 2 and then -1. And then let's use these variables for the x and epsilon of the position of our creatures. So let's try again. Alright, here are our creatures. So we can actually just also attach this to the draw, the method from the GTWorld to the draw function, because in this way we will have a continuous rendering of our world. We can also check the frame rate with the JIT FPS GUI to check that we didn't do anything that is breaking our frame rate. No, so still looks good. Okay, so let's just move all these creatures in, or maybe let's make them move in a random direction. Okay, so let's give a new property to our creature class, which will be this dot velocity, so the velocity of our creature. And let's give it also random velocity. So let's create a couple of variables. So random vel x, and let's create again. Let's actually just copy this, but let's multiply all of these for a much smaller number, because otherwise they will just go super fast. So, and then let's say random vel epsilon, and the same. Okay, so this velocity will be a new vector with random vel x and random vel y and z, 0 for the zeta velocity. Okay, so now our creatures will start with a random velocity, and then let's actually create a new function. So this dot move, or maybe let's just use the nature of code style, and then let's call this function update. And then let's say this update equal function, so this dot position dot add, so we are now using the function add of our vector class. This dot add this dot velocity. Okay, and we will call this function before. Oops, there is an error. There is a part. Oh yeah, I just put this in the wrong place. And this will call this function before calling the function display. So we will call it here. So creators I dot update. Alright, so oh, and they're gone. So let's try again. I think this speed is a bit too fast. So let's multiply it. Let's actually create a new variable here, and let's call this. Let's create it actually as a variable, as a property of this class. So this max speed equals 0.03, for example, and then let's multiply the velocity, the initial random velocity for this max speed. So, and okay, and they're gone. Now we could make in a way that when they disappear from the window, they just will appear on the other side of the window. So to do that, let's create a function inside our creature class. We will call like this dot check borders, something like this, equal function. And let's write something like if this dot position dot x is less than -1, so this will be our border on the left, or this dot position dot x is greater than 1, so this will be our border on the right. This position dot x is equal to minus. Actually, let's just multiply it by -1. So yes, so let's multiply the positionings by -1, and then let's actually do the same with the y. So if this position dot y is minus than 1, or it's greater than 1, then this position dot y it's equal to this position dot y multiplied by -1, which means it will actually just change the sign and should make them reappear on the other side, which doesn't seem to work. Oh yeah, because we didn't call the function yet. So let's actually call it in the update function. So after we sum the current position to the velocity, let's say this dot check borders. Okay, so and see. All right, seems to work. Seems actually to work. I think the speed is still a bit too fast. So let's change the variable max speed to something a bit smaller, to 0.01 for example. Okay. So you see, when they disappear from one side, they will just appear back from the other side, hopefully. Oh yeah, no, that's actually right, because if the position y is greater than 1, for example, in this case, then it will appear in the same x position, but on the opposite y position. So yeah, this looks correct. So maybe then we may want that instead of just reappearing on the other side, they just cannot go through the edges, and they will just kind of bounce off. Let's actually do it like this. So let's make that they bounce off the edges instead of reappearing on the other side. So let's do it like this. So let's say instead of saying this position.x equals -1, let's say this velocity.x equals -1 and this velocity.y per equal -1. So they should now exactly. So now they are bouncing off the edges. The problem with the y edge is that they are going a bit too far, because actually this is not exactly -1 and 1. That's because our camera is a bit too close. So we should actually, since we anyway not care about the depth, we should actually use orthogonal projection. So let's say ortho 2. In this case, since we care anyway only about the x and y axis, this will actually behave in the correct way. Yes. So, all right. So this needs to work. The thing is that now it will this position actually doesn't include the radius of the circle, so it will not bounce off to the exact edge, but will bounce should actually bounce on the center of the circle. So we have to put the radius into account. So let's go here and let's say if this position dot x so let's create a parenthesis plus, because we are saying it's minus then -1, so we are on the left side now. So plus the radius, so plus this dot size is less than -1, or this position dot x plus the radius dot size is greater than 1. So let's see if this works. So there is some of these guys that got stuck. So there is probably a bit of stuff to fix in this code. Let's see. Ah, yeah, because then we say it's multiplied for the same, is equal then to the same velocity multiplied by -1, so actually the opposite velocity. But then it could still be less than -1. So so this will actually mess it up. This will actually then make it just get stuck. So let's actually say this position is actually less or equal. Let's see if this helps. So I think this could actually help. So by the way, let's do the same for the y. So if this position dot y plus this dot size is minus than -1, or this position y plus dot this dot size is greater than 1, and then let's say minus or equal or greater or equal. Okay, and let's see. Oh no, there is still somebody that gets stuck. That's because when they are minus or equal to -1, the velocity is continually changing and not bringing them far enough. So what we should do is actually first bring the position a bit farther from the border. So to do this, let's maybe do something like this dot position dot x minus equal to this dot position dot x multiplied by a really small quantity. So let's actually try if this kind of helps, because then in this way we bring a bit the position a bit back. So for example, let's say that they are here on the edge, so this will be our edge at 1. And then in this way, wherever they are too close to the edge, so wherever they pass the edge, they are equal to the edge, the position will just get adjusted to a place near to the edge, but not exactly less to the edge or equal to the edge. So this should kind of work. So let's actually copy the same code into the y part, so let's actually copy it. Okay. So I think this kind of fixes it. Now the only problem here is that we should take into account the fact that the windows gets resized, and then the x will not be anymore at -1 or 1, but will be actually the ratio of our window. So let's take this into account, and let's take the ratio of our window. To do that, we will use the get at sides. So we will get with that the size of our window. So every time we, for example, resize the window, we get the dimension of the window. So let's divide one number by the other, and we get the ratio of the window. Alright, then we have to pass this to the JS file. So let's actually create a new global variable here. Let's call it ratio, or window ratio. Let's set it to 1 by default, and then let's set a function like set ratio. And then let's give it an argument, and then let's say window ratio equal r. Alright, and then we will use this window ratio inside this check border function. And this will be the border for the x. Not for the epsilon, because the epsilon will always stay between -1 and 1. Alright, so let's call this function with set ratio with the ratio. Let's connect it here. And for example, if we resize our window, now the creatures will kind of run to the edges. I see that there is an error here on the left, because they still seem to... Oh, okay. I think in fact because we have to say not plus here, but minus. And I think the same thing is valid for the epsilon. Because in this way, the position.x, oh yeah, because here we are on the negative axis, so we have actually to subtract the radius of the creature in order to have the correct calculation. So yes, this seems to work. Alright. Alright, so this will be the start of our ecosystem world. I think this is going to be funny. I really want to develop something that looks then interesting in the end, in which we cannot actually predict how it will behave. So cool, thank you for following, and let me remind you that I have a Patreon account, a Patreon page, on which you can support me, and you can actually download a lot of max patches for the visuals. Alright, so hope to see you in the next video. Ciao!